Hello there everyone. So this is a question from Ch4, I believe. It's the chapter review from chapter 4, extended response question 5. It says an equilateral triangle ABC circumscribes the circle with the equation x squared plus y squared equals a squared. The side of BC of the triangle has the equation x equals negative a. And you can be sitting there going, what the hell does this mean? And that's completely fine, because that was my first reaction looking at this as well, and it takes a little bit of working out. So quickly, I'm just going to do a little sketch to show you what's going on and what these terms mean. Okay. So, equilateral triangle ABC circumscribes the circle. So, that's meaning there is a triangle around the outside of a circle and it's just touching the circle. Pretty much its lines are tangent to the circle. It just touches, doesn't bisect, it just touches it at the sides. Okay? So let's do a quick little sketch. Means I have a circle, or a circle-like object. Actually, I can do, so I have a circle like that, and then I also have a equilateral triangle. Now, I don't know if this is going to let me rotate this. No, it's not. Okay, that's all right. But we have an equilateral triangle. Yeah. Okay. The thing with this is it says it has a side, and I'm going to leave that there just for reference. All the sides are the same length. We have a side, okay, the equation x equals negative a. So first off, from our circle, it's not translated anywhere and has a radius of a. So right there we have a 0 up here, we have 0 a over here, we have, importantly, negative a 0. Okay, we have an equation, one of the lines at the side. Okay, so from here to here is x equals negative a. Now, x equals a constant, some form a, negative a. That means it's a vertical line up and down. So we have a triangle with one vertical line there. Okay, and this equation is x equals negative a, and we have point B up there, point C there. Okay, so that means the other two sides just touch the circle, come out to some point out here. Just touch the circle, come out to some point here. And this is an equilateral triangle. Each side is the same length. We have ABC. It circumscribes the circle. So that's the problem we have. Okay. Part A, find the equations of AB and AC. So it wants us to find the equation of this line here, AB, and it wants us to find the equation of this line here, AC. So they're lines, they're straight lines, so we know we're chasing something. Y equals mx plus c. Okay. M's our gradient, and c is our y-intercept. So how we go about this? Well, it's pretty full on. Need to use similar triangles. We're using Pythagoras' theorem. There's a whole bunch of things going on in this problem. So let's have a go at it. First things first, what I'm going to do is I'm going to split this equilateral triangle in half. Okay, split all the sides in half. So from there, there, there. Okay, and I'm going to call one of these halves B. So that's B there, that's B there, that's B there. They're each B length. I'm going to call that B. And we know our radius length up to there is A. Right, so we have that. And this would be a right angle triangle in here. I'm going to start with doing something a little odd. and I want to find out the length of along here. Why do I want to find out the length of along here? Because if I split this equilateral triangle in half, okay, something that looks like this, right angle, I have one side B there. This side along here is actually 2B, okay, because it was B there. And this is the equation of the line I want to find. I want to find the equation of this line. So I'm going to call this base here just for now M. Now, why am I wanting this base? Because, actually I'm not going to call that M. That's going to lead to confusion. I will call this, let's call it C. Okay. What do I want to know C? Well, the equation of this line has a gradient, an M value, gradient equals M is equal to rise over run is equal to, okay, it's going to be a negative B on C. Okay. This is still not telling me. The only thing I've been given at the start is an A, so I need to get these two in terms of A, or figure out what happens here if I just get a nice constant. So I can use Pythag to find out what this C is. So let's go 2b squared, the hypotenuse, is equal to b squared plus c squared. So c squared is equal to 2b squared minus b squared. C squared is equal to 4b squared. This square should be on the outside. 4b squared minus b squared is equal to 3b squared. So C is equal to square root of 3b squared is equal to root 3b. So I can sub that in over here. So my gradient is equal to negative b on root 3b. Lovely thing about that is the b's cancel, and it's giving me my gradient. So my gradient of this line across here is going to be equal to negative 1 on root 3. So already for this top side, I now know it is y is equal to negative 1 on root 3x plus some c value. And the c value is the y-intercept here and here. Now we can't get anything about those y-intercepts from the circle. It would be really, really complex, really convoluted. Instead, if I found the coordinate of one point, just one point on the line, if I know my x and y values, I can substitute that in there, and that's going to give me my c. So that's what we're going to try and find. We know this is negative a, and it's going to have a height of b. But our b is not useful, okay, yet. It was just some random thing. We called it b. We need to figure out what this b is in terms of a. Okay. And once we find that, we can substitute it in, solve to find y-intercept. The beautiful thing, since this is an equilateral triangle, we will have the exact same equation for this line here, but just times by negative 1 because it's a positive gradient. So how do we find that coordinate? Well, we're going to use similar triangles, and seeing the similar triangles is a little complex, but I'll show them to you. So this radius, I'm going to make it a solid line, okay, and that radius I'm going to take it to the tangent point, so that's going to be at right angles to the tangent. So I'll draw it over here, right angle there, we have radius A, and this angle down here I'm going to call theta. So we have this there, and the length, because I split it there in half, that length there is going to be B. Now if I look at the large triangle, this same one over here, okay, looking back at this, which was the full top half, that has a right angle, and that also has the same theta. So I'll redraw it. Okay. And that has a length 2b there and a length b there. Okay. these are similar triangles. They're different sizes, but they're similar triangles. Using these similar triangles, I can actually find out what this B is in terms of this A. So a similar triangle, the ratio of the sides is the same length. So if I do that divided by that is going to be equal to, so short side divided by long side is going to be the same as short side divided by long side. And I'm going to actually use that to find out what B is in terms of A. So let's do short side divided by long side for this triangle is equal to short side divided by long side. I'm just going to double check, make sure I'm getting this right. Bear with me one moment. So I'm going to end up with A is equal to B squared on 2B. So A is equal to B on 2. Hold on, I think I've made a mistake. I'm just going to leave you here for a second. Yes, I knew I made a mistake. Okay, so to highlight the mistake, I did short side divided by hypotenuse, and this is short side divided by the base, not the hypotenuse. So that's where my mistake is. I knew I had needed a root 3 in here. So I'm just going to delete some stuff. Delete that. Okay. So I had short side by base, so I need to, we care about down here. This is the bit we care about to get the same ratio. I thought that was too easy. Apologies if you noticed that much quicker before I did. Okay, so down here, the length of this base, okay, we found it in this, the C, but we may as well use B since we have that. It was root 3B. Okay, so short side divided by long side is equal to short side divided by long side. Much better. So A, we know this length is B, we want it in terms of A, so I'm going to solve this for in terms of B. So I'm going to rearrange, so we have B on root 3B. I'm just switching sides here to make it a bit clearer, equals A on B. I'm going to then get B is equal to A root 3B on B. Cancels, cancels. So B is the same as root 3A. Okay. So I now actually have the coordinates of this point here. The coordinates of that point there are negative A root 3A. And I can substitute that in to my equation that I have so far, and that'll give me my C final component. So we have y is equal to negative 1 on root 3x plus C, so I'm going to have root 3A is equal to negative 1 root 3x, oh, not x, I'm going to put in negative A plus C, so you get root 3A is equal to A on root 3 plus C, so C is equal to root 3A minus A on root 3, and let's have a look. We might rationalize this denominator, okay, just in this bit here. I'm going to rationalize the denominator, so Rationalising means getting rid of the surd on the bottom, so I'm going to multiply this by root 3 on root 3. So I'm going to get c equals root 3a minus root 3a on, and so root 3 times root 3 on the bottom is just going to give me 3. So really this is saying, to see it fractionally, we have root 3a minus 1/3 root 3a, so that gives us 2/3 root 3a. So that's my c value. So finally, I have my equation y equals -1 root 3x plus 2 root 3a on 3. Okay, so I have an equation for this line, this yellow highlighted line. Okay. This line here will have the exact same gradient, but instead of negative it will have positive, and the y-intercept instead of positive will be negative. So that was the line for AB. The line for AC is going to be y equals positive gradient x and then a negative y intercept. There we go. That's part A done. Part A done. I hope you're stuck with it. If not, that's okay. Like I said, this won't be on the test. Not this complex. Not this complex. That's part A. Part B. Find the equation of the circle circumscribing the triangle. So since now it's circle circumscribing triangle, this is saying we have a new circle that, and this is going to be hard to draw, new circle around the outside. And it has this radius from here all the way out to here. It goes, it's touching A there. Part B. So we've got this new circle around the outside. So center is still at 0, 0. That's the nice thing. Our center is still at 0, 0. And quickly, we know 1 point on the circle. We know 1 point on the circle. Okay, going through there, point A. Point A. So keep that in mind. We have this equilateral triangle. We have now this new big circle going around. At the center is that. So we know our equation is x squared plus y squared equals r squared. And all we need to do is find that spot there. That'll give us our radius all the way from the center. How do we find it? Well, we know this equation of this line, okay, and which was we set up here, is y equals -1 root 3x plus 2 root 3a on 3. Okay. This point here is when y equals 0. So let y equal 0. So we get 0 equals and now we just need to solve for x, which takes a little bit of work, of course. So we get -2 root 3a on 3 equals -1 root 3x. So multiply by root 3, we get -2 root 3a root 3 on 3 equals -x. That's going to cancel, or not cancel, but the square root 3 times root 3 is the same as root 3 squared, which is just going to be 3. So I get -2 by 3 by a on 3 equals -x. Now my 3 and my 3 are going to cancel, so I get -2a equals -x, or x equals 2a. So my radius, the coordinate of this point here is 2a, 0, Okay, so my radius is 2a, so my equation of my line of my circle, x squared plus y squared, equals 2a squared, or that's it. So this circle that circumscribes the triangle that was circumscribing our original circle, this circle inside had a radius of a, and this bigger circle has a radius of 2a. And that's what's happened there. And then written, oh, yes. That's it. Again, hope you stuck with it. If not, that's okay. Thank you very much. Bye.